I would like to give the floor for the Nobel Prize, Professor Rick Leemans, who is head of the chair at Wageningen University on ecosystem service analysis systems, which is also very nice topic, and he's leading many journals, international journals, as an editor, as a supervisor, and many other distinguished things which he's doing. So Rick, floor's yours, and we will be happy to hear you, and very honor for us. Thank you.
Thank you very much, Professor Pilatov, and all the nice words. I'll share my screen if I can do it from here. Talk very much about our activities with respect to biodiversity, land use, and climate change. And we see climate change very much as a driver of change. It's a global, international issue, while the land use and the biodiversity is much more local. And I'll show a little bit how we actually develop our models, what's in it, but also how we apply them to support international policies. And in the end, I will talk a little bit about an application in a European project called the Impressions project, where one of my PhD, Savannah Nunes, did an analysis with different scenarios for the Central Asian grasslands. And she really showed how vulnerable that area is. Now, if you look at my career, I've been working, I'm trained as a forest ecology in Scandinavia, but I've been working very much on global change issue. We're trying to integrate carbon, biodiversity, land use, and climate, but focusing very much on large-scale models. And that's what we did in integrated assessment, is very much to support biodiversity. Now, this word cloud comes very much from all my published papers and the title, so you see what kind of words are very important. And recently I published a paper where I actually reviewed the scientific support of the 2 degrees or the well below 2 degree target of the Paris Agreement. How much is that actually scientifically motivated? And it very strongly is. And amongst others, my work also contributed to that, and I'll show a little bit that in this lecture as well. So if we look at the world, and this is a very distorted world with Europe at the center, but Central Asia is still in the picture. It's one of those night vision pictures where you actually see where people live and you see the impacts of people. And you also see a little bit the structure of the countries. And Moscow is very clear a central city in Russia, while a lot of the European countries are much more distributed, except for France then, and England also with London. But we see a very strong human pressure on our planet. And it's actually a very unequitable pressure. For example, 20% of all the people use 80% of the resources, and that's not fair. It's very much in the Western world, and also from the emissions that the Western world has the largest emissions of the greenhouse gases and uses most of the resources. But we also have climate change, and one of the dilemmas there is what kind of climate change can we actually allow? Is it 1.5 degrees? Is it 2 degrees? And we get much more the insights currently that we actually have to stabilize the concentrations in the atmosphere as soon as possible. And that means that we have to reduce the emissions very, very quickly. Now, fortunately, over the last half year, the European Union presented its Green Deal. China presented a very ambitious emission reduction program. After China did that, Japan did the same. And in the last few months, about 70 countries really pushed strong emission reduction ambitions. And we calculated a little bit in our models what that would mean. Now, immediately after the Paris meeting, the promises to reduce emissions would lead to about a 3.5 degrees increase. At the moment, with all the promises, it's actually 2.3 degrees. So we're getting closer to the 2-degree target. If Biden will be effective in actually implementing his climate policy plans, then it would even be 2.1 degrees. And so it's really moving forward. But on the other side, we also see the decline in ecosystems. We see a loss of species, partly because of destruction of habitats, exploration, and very much human activities. And that will affect the ecosystem services that we all depend upon. And of course, there are interactions between ecosystems and climate change, and that could actually make things worse. And finally, we actually believe that all these changes are gradual. But over the last few years, we have seen many more extreme events. They are not gradual. They're tipping points, etc. And there are surprises. And there we really have to look at the events with a small probability and a very high impact. We're not very good at that. In hindsight, yes, we are, but not to predict these kind of surprises. So that's very much the challenge that humanity is facing. How do we actually increase solidarity, increase equity, and solve these different problems at the same time? Fortunately, the heads of state set the Sustainable Development Goals, and we should move towards that. And our research very much also contributes to that. And my group contributes to UNFCCC. I've given often the science lecture for the Conference of Parties. We also contribute to the Convention on Biological Diversity by providing some of the background science, by giving advice to the advisory and technical issues. But most we do is actually through the science policy assessments of IPCC and IPBES, the Intergovernmental Panel or Platform on Biodiversity and Ecosystem Services, which is similar to IPCC, but then for biodiversity and ecosystem services. And in my career, about 20 years ago, I actually chaired one of the working group of the Millennium Ecosystem Assessment, the Responses Working Group, together with Kanchan Chopra, an Indian economist. And that was really a learning curve on how to actually deal with the biodiversity and ecosystem services issue. So we focus very much on that. Together, we do that with a lot of Dutch governmental institutes and very much with the universities. Now, this kind of work is generally not paid. It's very much voluntarily work, but it is very, very important to actually get the science towards the policymakers. And I very much enjoyed it, and it gave me a lot when you actually review all the literature. And next week we have a workshop of IPBES and IPCC on biodiversity and climate change. You actually learn a lot, and you also learn what we don't know yet. So it helps to actually set research agendas as well. Now, if we look at biodiversity, we have developed together with PBL, that's Professor Rob Alkemade, a very nice indicator to measure the level of biodiversity and the decline of biodiversity. That's the mean species abundance. That's actually a group of species which you take and you look over time how many disappear from a region, how many go extinct, etc. And you look at the abundances. But you look also at the amount of habitat which is still available. So it's both a species-based index as a extent-based index. And it's gives an impression for biodiversity intactness. And it's very simple to implement. We wanted to have a simple indicator that could be applied even if there is little data, if you have only satellite data, for example, etc., and not all the detailed species data like we have, for example, in the Netherlands. There every square meter is almost monitored and documented. It's not done in many other countries. In the Netherlands, we do it very often through citizen science, where a lot of lay people contribute by documenting and monitoring species and events. Now, if we look at our models, they are very often looking at the causes and the effects. And so it's very much looking at the drivers, the pressures, the states, and we have two major models. One is the image model, the integrated model of the global environment, very much a climate change model. And we have GloBio, which is our biodiversity model. And with that, these two models combined, we actually look at possible responses and try to assess how we can deal with the environmental problems and how we can, in climate, actually move towards the 2 or 1.5 degree climate change, and with biodiversity, how we can actually manage our resources such that biodiversity will not decline. And if you look at the models, they're actually quite complex and they have a lot of different factors in there. And the image models looks at the demography, the world economy, trade systems, energy supply and demand, land allocations, the different emissions, the atmospheric chemistry, climate change, but also the carbon and nitrogen cycles, and then very much the impacts of climate change. While GloBio looks at some of the drivers of biodiversity change, like nitrogen deposition, climate change, infrastructure, which destroys habitat, and land use, which changes habitats. So it's a whole set of complicated models, data sets, which actually create our...
Yeah.
Okay. And what we do with these models is actually you have to validate them, you have to parameterize them. So we use a lot of data sets to actually do that. And a lot of those data is publicly available. Other data is again published. But you see, if you look at the data, there are an enormous data clouds, and you have to actually distract the relationships in there. Some are significant, others are not, but then you link it to theory and how about the assumptions on how the world works. So all these things are in our models. And actually what you also see, if you implement the models over time, you actually see threats to biodiversity. 5,000 years ago, few people, few threats, and the world was more or less natural. And then you, over time, and especially the last century, you see big threats to university. And if you then actually project that into the future, like this picture up to 2100, you actually see increasing threat on biodiversity. If population doubles, if the economy quadruples, if climate change continues, etc., etc. But you see also large differences in the world. And that's very much what we try to assess. And here you see one of the outcomes in a big scenario study of the mean species abundance, the indicator, and how that actually would or has evolved over time for the different biomes of the world. And that's kind of data we actually produce for the convention or for the science policy assessment. And in the red circle is our Professor Rob Alkemade, who's actually in the panel and one of the leaders of one of the working groups of IPBES. So we have, as a group from Wageningen, also direct influence in these kind of processes. Now this picture is partly my work. On the left side you see the IPCC scenarios of climate change. The vertical axis is actually the amount of climate change. Now all these scenarios given, all these different lines, are without climate policy. And you already see that without climate policy, both sustainability or energy policies, you can go from 2 to about 6 degrees in this century. And on the other side is actually a figure I made now 20 years ago for one of the IPCC reports. That's the reason for concern figure. And the literature, it's now also known as the burning ember diagram. And that's very much a figure which synthesized all the impact literature for ecosystems, unique and threatened systems, for extreme events, so storms, droughts, etc. The distribution of impacts, so regional impacts, global impacts. That was actually very difficult to do because it depends how you measure. And the richest people, which are less impacted, live in the Western world. The poorest people, which are very badly impacted, live in the developing countries. So if you take a metric which is just based on euros, you actually get not so high impact. But if you look at how many people are affected, you actually get very, very big impact. So the assessment there is very much depending on what indicator you may take. And the last one is very much on these surprises, the large-scale discontinuities. And initially we had to figure green, yellow, red, like a traffic light. Red was dangerous climate change, and very much in the climate convention, it's objective to move away from dangerous climate change. And that's the red color. The yellow had a small risk, and the green initially we said there's little risk, but actually a lot of people interpreted green as being safe, and safe is not the same as little risks. So that's why we made it into the color white. And if you look at this diagram for the first bar, you actually see how important ecosystems are. There are some extremely vulnerable ecosystems. Those are the coral reefs. Probably if the global mean temperature increases to 1.5 degrees, most coral reefs will bleach, will start to disappear. A lot of our CO2 is also captured, absorbed in the oceans. That leads to ocean acidification. And these calcareous organisms actually cannot handle a more acidic ocean. So they are vulnerable from two different directions. The polar regions, the mountainous regions are also very, very vulnerable. And so the tundra, the alpine type of vegetation. Coastal regions with sea level rise, and that depends on the type of coast, depends on the magnitude of the sea level rise. But we also see some of the crops which are very vulnerable, like grapes. Most of the champagne grapes are now already grown in England and not in the Champagne region, because the Champagne region is getting too warm. In the Netherlands, we actually see a lot of vineyards popping up, and there are more families depending on growing wine than on fishing. What's the English name? Torsk. And coffee is also one of the very sensitive crops. It's not so much the Robusta coffee, what's in the name, but very much the Arabica coffee, which needs a very specific moisture in the air to actually ripen and fully ripen its teeth. And you, of course, also see some of the species which are vulnerable because the habitat will disappear, like this polar bear. So that made us make the assessment that the vulnerabilities of ecosystem are already there. We see many negative impacts at the moment, but they become really strong about at 2 degrees change. The same was actually for all the extreme events, forest fires, droughts, fires, etc., etc. And the picture of Europe there is the heat wave in Europe in 2003, which actually caused almost 30,000 casualties. And so there's a very similar risk profile as the ecosystems. And that helped to argue actually for the 2-degree target of Paris. The third one, very much the regional impact. And you actually see that most of the emissions come from developed countries, while the impacts are in developing countries, because these countries are much more dependent of climate-dependent sectors like agriculture, like water, etc., etc. So there's a very different pattern, but the balance of risk is a little bit higher. The same one with the last one, the global impacts, very much sea level rise and the surprises, the changes in ocean current, melting of large-scale ice in Greenland and Antarctica. At that time, 15 years ago, we actually concluded that these would not be happening this century. Maybe it would be triggered, but the impacts would be much, much later. Therefore, the risks are much, much higher. Since a lot has happened in these kind of assessments, we now have observed impacts almost everywhere in the world. We see changes in water systems, we see changes in ecosystems, we see changes in agriculture and resource use, and we see changes in livelihoods because of climate change. And many of those cases are actually quite well documented at the moment. And one of my PhD students, Gerrit Hansen, actually made this map for the IPCC and also wrote her thesis on it. And sometimes in her research, she shows how difficult it is actually to do the attribution. It's relatively simple to do the attribution of local climate change to the impacts, but then to relate it to global climate change and emissions is much more difficult. There are lots of uncertainties in there. But we have these observations, and they actually show that the initial reasons for concern diagram was much too conservative. So in the latest IPCC report, they added the color, the purple color, very high risks, very dangerous. And you see for the ecosystems, the purple color starts at 2 degrees and the red already starts with 1 degree. So with the knowledge of the last 15 years, we actually now know that a lot of systems are much more vulnerable for climate change than we thought before. And that's also with the decline of biodiversity. This week, IPBES released a report on the biodiversity decline and the pandemics, and they actually observe a very clear link between them. And that the zoonosis, the pandemic viruses actually occur more frequently because how we deal with nature. But also in the extreme events, it's getting lower, the distribution impacts, the global impacts, and the large-scale events. So you really see, and that's the discussion of the last 5 years in the climate convention, that we actually should not focus on 2 degrees, but we should focus on limiting climate change to 1.5 degrees. That's a very, very big challenge to actually do that. Now, if we look at how we do actually the work, I want to take one example of my PhD who actually defended her thesis this spring, Sarah Nunes, and looks very much at the interaction between land use change, ecosystem services, and biodiversity. And she develops a whole set of models and looks at these kind of processes and drivers. And one of the studies she did was actually as part of the Impressions project, where she looked at Central Asia, and she used the latest IPCC scenarios, that's both the climate scenarios but also the socioeconomic scenarios, to define the different land use scenarios, to look at how the Central Asian grasslands were used with different projections for grazing intensity, etc. And there she took a very nice spatial analysis based on satellite data with a high resolution, and then overlaid that with the Globio approach to look at the impacts of climate change and changes in land use on these grasslands. And if you look at her pictures, she has the baseline data, that's the bigger map of the regions, and then she has taken four of the socioeconomic pathways which are used by IPCC to actually depict different socioeconomic systems, different future socioeconomic systems. And with the pathways, she actually projects to 2040, 2070, the middle column, and 2100 at the moment. And you actually see different impact level. This is very much only the land use changes and the intensification on the grasslands as part of the driver. People want to have more meat, more cattle, etc. in some of the scenarios, and less in other scenarios. SSP3 is, for example, a much more sustainable socioeconomic scenario. And then if you combine it with climate change, you actually see that the situation is getting worse. A lot in the region will be more droughts, less precipitation, higher temperatures, more evaporation. And so you see the combined effects of the changes in land use with climate change, but also with different climate scenarios. And the RCP 8.5 is a very high emission scenarios, 4.5 is a benign emission scenarios. You see the difference in them. If you have a very big climate change, you get much bigger mutual effects of land use and climate. So in their conclusions, on her conclusions, she actually very nicely shows that using these models and comparing them with similar approaches all over the world, that the Central Asian grasslands seem much more vulnerable than grasslands, for example, in Argentina or the US, etc. Partly because they are so strongly landlocked, but also that the land use and the developments have to take into account. And you have to actually start looking at how do we make those grasslands, how do we manage them better and make them less or more resilient against climate change, so make them less vulnerable. And so her study shows the potential impacts. She hasn't looked yet at all the possible adaptations and responses, but that's very much working with the stakeholders, the local stakeholders, and using this kind of information to actually come to a much more adaptive land use. And together with the rest of the world, we have to reduce the emissions to actually move away from the high climate change scenarios to a much more benign climate change scenarios. And a lot of our work, but also work from others, show it's possible, but we actually have to push the political will to get there. Thank you very much. You are still muted, Alim.
I take it out that is not disturb your presentation. As we discussed earlier, that we probably have questions to you from auditorium. And I saw already in the chat that dear Professor Leemans, what do you think about the global grid data reliability to specific deltaic region and oasis in the arid zone, like CIGR, climatic aridity indexes, and other derivatives. Is it okay? Question?
It's a very interesting question, and also a very essential question. It very much depends on the data you have. And if you have very poor data, you have to make a lot of assumptions. Generally, our data for land use are relatively well established. We have high resolution data sets there, but there is, how do you translate what you see from a distance by satellite to actually the parameters you want to measure in the field? Now, there's also a lot of progress in the last half century on that. We can do a lot with satellite data, but that's very much on the vegetation, on the land cover, etc. The climate data, there are regions which do not have many climate stations, so you have to interpolate. Regions with a very diverse topography are more difficult than flat regions like the Netherlands. So it depends a little bit on the data you have to actually assess its quality, but you always have to assess the quality before you start doing these kinds of calculations. When we use in GloBio the MSA index, we actually use it because it's not very data demanding. And you can actually implement it with relatively simple, straightforward data that is generally available. But if you would start using a very complex index, then your reliability will go down.
Okay, thank you. And I believe that the question from Karakalpak State University, it's answered. Any other questions? So sometimes it's for me interesting, so I probably will take my position and give the question also. But first, we try to use the ability and interest of our auditorium. So we have a specific session on climate change, and I guess is also I saw the question about from Irina. She asking is that very nice presentation, interesting presentation. It's interesting data about our Central Asia. So is it can we use it, because I saw it's from publications, yeah? So that's already so
it's already published in Regional Environmental Change.
Yes. So it's a part of the publication. So that's Irina, some part of the answers, your question answered, but do you leave the presentation if it's up to you? Yeah, leave.
I will send my PowerPoint to you, Alim, and you can share it if you want to.
Okay, so it's this question also answered. I think there's other questions, please. So we have not much time, but still Professor Leemans with us, and then okay, this you done the job as this recently published data. So I heard that the IPCC, I mean, they I'm not very often doing the climate change exercises, but in our group you remember Bakhtiyor and also your Slava also defense degree, PhD. So we're working together now in the CIS countries. So it's also good opportunity where the Wageningen alumni working together. And also we're talking about how this model, it's a model was developed by your chair of Wageningen University, or how it's as I understood.
Now, the models were developed by PBL, so the Dutch Environmental Assessment Agency, and that's still the institute who is responsible for them. But before I became a professor in Wageningen 15 years ago, I led the model development at PBL. So it's a little bit inbreeding the connections.
Okay, so this model can be used, or how? Yeah, or it's just a license.
In principle, the GloBio model is published and can be used locally, regionally. It's very easy to implement and to use it. So that's possible. The image model is much more difficult because it requires a bigger computer, it requires a lot of data, and a very skilled programmer to actually bring all the things together and to interpret the results.
Alumeke, can we ask a question?
Yes, I'm just trying to give myself because nobody wants to.
Professor Leemans, thank you. Your presentation is very nice, and I was very surprised about this model. And can you explain us where do you get such data? Because to make such models for a century is not easy work. As we know that when we're writing some articles, we need lots of data. Even we go for some entities to asking for data, and some of them are very reliable or some of them are very not reliable. And how do you get those information? And how do you? And this is the first question. And second one, what do you mean by making some dots there, red dots there in the map, in Central Asian map? And can you explain that?
Yeah.
Thank you.
The last question is relatively easy. The red dots are a very strong decline of the MSA index, so a very strong decline of biodiversity and ecosystem services. And that means that because of climate change, the current conditions will not be there anymore, and it will actually be very difficult to uphold a productive grasslands, and will probably move much more into a desert type of area under those high climate change scenarios. But I have to look at the details of the model outcome to actually analyze it, but that's very much my assumption. If you make these models, I've always been working since I got my PhD on models with a worldwide coverage. I don't say global because 2/3 of our globe is water, and I ignore water, except when I'm doing my hobby, which is sailing in a sailing boat, and I like water very much. But for my professional part, I very much look at land, and there are a lot of databases covering all lands. So there's the FAO soil database, there is the very high resolution topography database, there is a remote sensing based land use database, there is a whole climate database which actually gives the average climate for every month since 1900. So you can look at trends and the patterns, but all these databases have their limitations, but still they are the best that they are. So we actually use them. If we start doing like this study for the Impressions project on Central Asia, if we start doing those kinds of projects, we actually look at collaborators who have more detailed and better data for the regions. But our models are relatively simple, so they can deal with the coarse data. So you can conclude trends for larger regions and the world, but you cannot conclude anything for a locality. That's often a problem. People see a big map of the world and they validate the map with just the pixel where they live themselves. But these global maps, they have a resolution of 50 by 50 kilometers. Now, my garden is much smaller, and if I even look at an area 50 by 50 kilometers in the Netherlands, there are a lot of different activities. There's forests, there's nature conservation, there are cities, there are roads, there are rivers, etc. So we don't capture that kind of local heterogeneity. We look at the broader picture. And then there are a lot of statistical databases on municipals, on provinces, on countries, which give a lot of the socioeconomic data. And the challenge in these models is actually to link the socioeconomic data together with the spatial environmental data. And that can be done in GIS systems, etc. But that's very much our approach to do so. And we have been doing that for the last 25, 30 years, and sometimes very successful, sometimes getting very uncertain results. But you always have to look at those uncertainties and try to improve.
Thank you, Professor. Thank you.
You're welcome, Professor Adil Jeff.